Hello, this is Algebra 2. We are in Chapter 7, Section 5. This is page 2 of the notes. And here we have a couple examples. Hoping you'll just let me do them for you. And I want to actually change example 2 slightly because it's not actually quite hard enough. If you do it yourself, that's fine. If you already did it without trying to watch or whatever, that's fine. But let's go ahead and change example 2 from log base 3 of 7x squared over y to log base 3 of 7x squared over y z. So put a z next to that y at the bottom, if you would, please. I ask because I know it's coming up in the checkpoint and on the homework assignments, and I want to make it sufficiently challenging. So here's what's going on. You've got this logarithm, and it's got a lot of junk in it, and you need to make it separate logarithms that are individually very simple. So there's a thing on the side in the bubble, what I cut off for this, but it says assume that the variables are positive. All that means is don't worry about things breaking. You probably weren't worried about things breaking already, so you really don't have to worry about it. That's all it means, which means don't worry about it. So they probably shouldn't have put it there. Oh well. Here we go. We got log base 3 of 7x squared divided by yz. And so the quotient property comes first, and that's because it's kind of like solving an equation. You're unpacking it one piece at a time. You're not doing it. You're not doing the order of operations. You're undoing it. So you've got to undo the outside junk first, and that would be the division, because that is what happens last. So it's log base 3 of 7x squared minus log base 3 of yz. Boom. Quotient property. Now the product property. Okay, so here's what's going on. You've got your 7x squared. That is two things multiplied. So that's log base 3 of 7 plus log base 3 of x squared. Boom. And maybe I'll just draw a couple arrows like zoom, zoom, with the plus in between. All right, now minus, same thing here. You got the yz, right? So, oops, excuse me. Log base 3, that is a terrible 3. Log base 3 of y plus log base 3 of z. And again, you had that multiplication, that product business being broken up into two separate pieces with addition in between them. And that's wonderful, but there's the trick here, which is why I changed the problem. This was all being subtracted before, so boom, 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 it needs parentheses around it. I drew brackets to be dramatic, but parentheses are just fine. And the reason why is because that negative actually distributes. It's negative log base 3 of y minus log base 3 of z. And there's nothing exciting there. You just need to distribute the negative sign. Okay, looking at the beginning stuff, you had log base 3 of 7, and then, my favorite, that 2, that exponent 2, can come down in front of the logarithm. It's a free 2. It is no longer constrained in the logarithm. Boom. Log base 3 of 7 plus 2 times log base 3 of x minus log base 3 of y minus log base 3 of z. That is the answer. Separate logarithms, all of them as simple as possible. When you get those directions, that is what's needed. Example 3 is exactly the opposite. So you've got all these different logarithms. You got log 2, you've got 3 log 3, you've got log 9. They're all being added and subtracted, and you're meant to combine them together. Now, first order business is to take care of this 3. Now, this is kind of the backwards version of the thing I like. That 3 goes up and top. You might think it's because it's backwards of the thing I like. I might hate it or something, but nope, still love it. Now, as I write that, it strikes me that there's no base for these logarithms. And I'm like, wow, what happened? Well, we talked about this before, and I just want to remind us, if there's no base written, it means log base 10. This is actually incredibly unimportant for this, because all they have to do is match. And if they're not there, hey, they match. But I just want to remind you, if there's no base written down, it means base 10. Okay, so then here's what we're going to do. We're going to take the log 2 plus the log of 3 to the third, and boom, 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 boom. That's going to multiply. That's going to be 2 times 3 to the third. Because separate logs added is one logarithm multiplied. And that minus log 9 is just still hanging out looking for friends. And now that they feel secure, they're going to include it in their party. It's 2 times 3 to the third divided by 9. Right? So it's 2 times 3 to the third on top, 9 on the bottom. And now we're starting to feel like we've got a logarithm put together here. And so this is log, and then 2 times 3 to the third, that's 54, divided by 9, 6. Boom. And then if you're feeling spunky, you can write in the base, but that's entirely optional. Definitely not mandatory. All right, those are the examples. Now we have the checkpoints. I would again recommend you give yourself a chance here. So please pause it, try the checkpoints yourself, and then come back and see how well you did. I'll wait a few seconds so you can pause the video. Okay, this is the answer to number 3. We had log of 7y to the third divided by 4x squared. This division has got to happen first, so this division goes turns into minus between two separate logarithms, and that kind of follows all the way down here. Doom, doom, doom. Now let's see here. What's next? Then we had the 7y to the third, and that became two separate logarithms being added together. And then those dudes followed each other down the rest of the way. And meanwhile, the same thing with the 4x squared, right? Zoom. Let's see, what else happened? I had this minus with the brackets, or parentheses, whatever, because that was all part of the denominator before. And then had to distribute that. That was not terribly exciting. And then the powers came down. Oh, goodness, how I love how the powers come down, right? So that 3 as an exponent came down to the 3 in front. And then also with the x squared, the 2 as the exponent, came down with the 2 in front. Love that. Okay, that's how number 3 works. Try number 4. Number 4 is backwards version of number 3. Number 4 might be slightly scary because it has this Olin business. Talked about this before. I recommend that you always think log base e whenever you see that. But to be honest, it doesn't actually matter for this because all you're doing is combining them. So on number 4, go ahead and just combine them. Let's do the opposite of number 3. Try it on your own. I'll pause a few seconds so you can pause it, and then come join me and see if you got it right. Okay, here we go. Now the first thing we did was my favorite. Took that 2 that was sitting out in front of that natural log of x, put it up top as an exponent inside the natural log. Love that. Then go ahead and combine the separate natural logs that are being added into one natural log that's multiplied. And finally, take that subtraction business and make it division. Good problems. Thank you for watching.